Welcome back. This was the quiz question and your answer can be found here. So again, calculate the MRS. Take the ratio between prices, that's PA over 2 in this case. So at your optimal consumption bundle, your consumption of bananas equals 1/2 times PA times A. Plug that in the budget equation, gives you 2 PAA, that has to equal your budget, hence your consumption of apples should equal 50 over PA. If you don't get this, ask your tutorial teacher, your practical teacher. The crucial thing is, the way you calculate this is just exactly the same as before, but the things that are known are a bit different. So here, the price of apples is not known, so that will still figure in your final answer. You need a demand function, and indeed, this is a demand function, right? It gives the demand for apples as a function of the price. Which brings us to section 5.3. Okay, so let's again have a close look at the effect of a price change. So when the price of a good changes relative to that of the other good, then essentially two things happen. The first thing is that one good becomes relatively more expensive, the other one becomes relatively less expensive, so relative prices change. But your purchasing power also changes, right? If the price of a product decreases, then you can buy more stuff than you could before. You have more options available. You can do more with your money. So that's a different, separate effect. And what we try to do in this section is to decompose these two effects, to disentangle these two effects. So first of all, we're going to look at the substitution effect. So the substitution effect refers to the change in consumption due to a change in relative prices, but only a change in relative prices. So we keep your income constant, if you like, or rather we keep your utility constant, and then we look at what happens if these relative prices change. So when the price of a product increases, then while keeping your utility the same, this substitution effect will always be negative. When the price decreases, it will be positive. But then there's also an income effect. So the income effect, very similar to what we had in section 5.1, but the income effect refers to the change in consumption choice purely due to a change in purchasing power. And we have seen that this income effect can be negative or positive, because we can have an inferior or normal good. So when income increases due to a price decrease, then that could go either way. And the total effect is, of course, the sum of those two effects. Okay, this requires definitely some more explanation. So here we are again in our apple-banana space. Here we have a budget line. This is the initial situation. Initially, you're maximizing your utility by choosing point C, which boils down to consuming 3 apples, 5 bananas. But now suppose that the price of apples changes, and if you think about this, you can figure out that the new red budget line reflects a price decrease of apples, right? Your banana intercept doesn't change, so nothing changes to price or income there, but you can now buy more apples than you could before. In other words, apples have become cheaper. Okay, what is your new consumption bundle? Your new optimal consumption bundle is point D. You now consume 5 apples, 6 bananas. Okay, so this total effect, as I explained, is the sum of a substitution effect and an income effect. The substitution effect being only a change in relative prices, the income effect being the change in purchasing power. So this is the total effect. I now consume 2 apples more than before. But what about a substitution effect? Okay, so to find the substitution effects, we have to figure out what bundle you would choose at the new prices. However, we want that you're just as well off as before. We don't want your relative income to change. We don't want your income to change. So that means we want to keep you just as happy as before. So we want to get you back to your original indifference curve, right? We want to see the effect when you are just as happy as you were before, because we want to rule out this income effect, this effect that allows you to get on a higher indifference curve, but we want to maintain this substitution effect. We want to isolate the substitution effect. So what we have to do is we have to keep the new slope of the budget line. So we're going to take the new budget line because we're interested in the new price, new relative prices, but we're going to push it back, and we're going to push it back to the original indifference curve, because that gives us the situation in which we take away income from you to such an extent that you're just as well off as you were before. Okay, picture. So this is the new price reality, right? This reflects, this line reflects your relative prices. So let's take away some income from you, and let's take away so much income that you can just afford to reach the same indifference curve as before, because arguably in that case you're just as well off as you were before. So in other words, we're going to move your new new budget line down, but we're going to move it down such that it just still touches your old indifference curve. And in that case, your optimal consumption bundle would have been C prime, right? So again, the apple price has decreased. That makes you better off, but we want you to be just as well off as you were before. Hence, we're going to take income away from you such that you are just able to afford your original indifference curve, which implies pushing your old budget constraint to this red line. If this was the relevant situation before, then you would have consumed C prime. So in other words, the move, which happens to be 4 in this case. So in other words, the move from C to C prime, or in the case of apple consumption, your increase in consumption from 3 to 4, that's exactly the substitution effect. That is your change in consumption due to a change in relative prices while keeping your disposable income constant, keeping your original utility level intact, if you like. So that change from C to C prime is only due to a change in relative prices. You are compensated. That's a bit weird in this context since it's a negative compensation, right? But you're compensated for the change in real income. So the resulting change is the substitution effect. So that's the substitution effect for apples. This is the substitution effect for bananas. So the total effect is 2 from C to D in terms of apples, from 3 to 5. The substitution effect is 1. So the income effect, that's the other 1, right? That's the move from 4 to 5. So that's the income effect. So, in other words, in this situation, because relative prices have changed, my consumption of apples has gone up from 3 to 4. Apples are now relatively cheaper. And moreover, because apples have become cheaper, I can afford to buy more. And that implies another increase in apple consumption of 1 unit. So my income effect is also 1. It's the change from C prime to D from 4 to 5. Here also in the graph. and the total effect is 2 apples. Okay, so if you find this complicated, then that's because it is. This is probably the most complicated thing in this entire course, so don't despair. But let me go through the steps once again, right? So there are 3 steps to computing substitution and income effects associated with the price change. You start out with the original consumption bundle. You call that C. You draw the new budget constraint and you find the new optimal bundle. So that's what you're going to do after the price change. We call that D. That throws from C to D. That's your total effect. But now you draw a line parallel to the new budget constraint, but tangent to the old indifference curve. So we compensate you for your gain or your loss in income such that you end up at your original indifference curve. And we call that hypothetical bundle, if you like, we call that C prime. The substitution effect is the change from C to C prime, the old situation compared to the hypothetical situation. The income effect is the other part, the change from C prime to D, the hypothetical situation compared to the new situation. So that's how to decompose consumer responses to price changes into substitution and income effects. Okay, so earlier we talked about inferior goods, right? So let's look at how that works out in this example with this decomposition, because that's useful. Suppose we have a consumer and that consumer consumes steak and noodles. So here we have it, noodles and steak. This is the original situation. In the original situation, she consumes here A. This is the new situation, so the price of noodles has come down, and as a result, consumption changes from A to B. So the total effect is this area, right? How much noodles I consumed before and after the price change. Okay, there it is again. But now let's look at this substitution and income effect. Okay, so you know that we have to take the new budget line. We have to push it back in this case to your old indifference curve, and that gives us the consumption bundle you would have chosen without an income effect. So that's the substitution effect. The change from A to A prime, that's your substitution effect. That's how the change in relative prices affects your consumption choice while keeping you indifferent between the old and the new situation, keeping you on the same indifference curve as before. So that's the substitution effect. However, as you may see, this substitution effect is actually larger than the total effect, right? Remember, I'm talking about a price change, so the substitution effect always has to be positive. That's just implied by this curvature of the indifference curve, right? But the total effect is the sum of the two, so that means that the income effect in this case has to be negative. As you can see here. So what's going on here? Well, what is going on is that if we only look at the income effect, so then we filter out the effect of a change in relative prices, then we find that as relative income or as income increases, we consume fewer noodles. So in other words, noodles are an inferior product, according to the definition we introduced before. So here, noodles are an inferior good. Their income effect is negative. But still, the total effect is positive, right? Okay, so that also implies that hypothetically we could have a situation in which the income effect is negative, but it's even bigger than the substitution effect, right? Okay, we call such products given goods. Let me skip that slide for now and first show you this situation. So suppose that we consume potatoes and meat. And there's a price change in potatoes. Potatoes become cheaper, and as a result, we could have that so this is the new situation. So in this case, we have that the that the demand of potatoes goes down, although they become cheaper. That is a theoretical possibility. So what does that mean? That means that we have a substitution effect. That's not drawn here, but as always, the substitution effect from a price decrease has to be positive. But we have an income effect, and the income effect is even bigger in absolute value than the substitution effect, which implies that the total effect is negative. And that brings me to the previous slide. So that's what we call a given good. So a given good is an inferior good, but the income effect even outweighs the substitution effect, leaving you with a negative total effect. So in other words, that would imply an upward sloping demand curve. The substitution effect is smaller in absolute value than the income effect. So this is a nice theoretical possibility, but the question is whether such goods really exist, right? So economists have argued that sometimes that does happen with very poor households that can only consume that have very little choice in their diet and may have to substitute completely away from one type of product to another. So a famous example is potatoes in the Irish potato famine in the 17th century, I think, which is also where this example comes from. So there, the story is that if potatoes become very cheap, you want to buy more of them. Since I forgot the argument, I think it was actually the other way around. Yes, the other way around is what happened there. Potatoes became more expensive, and as a result, people were actually going to consume more of them. The reason being that, well, disposable income went down to still reach sort of the minimum subsistence level, what you need to survive. People simply had to eat more potatoes and consume much less meat to make that happen. Anyway, that brings us to the quiz for section 5.3, the quiz question for section 5.3, and that's actually an example from the book. So we have Monica, she eats chips and crackers. Her income is given. The price of chips and crackers are given $1 and $2. At these prices, she consumes at point A. When the price of crackers falls to 1, she consumes at B. And the question is, first, why does the budget constraint rotate? And second, what is the income? What is the substitution effect? Do try to answer this question before continuing, and good luck with that.